Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss application of derivatives. In this chapter, we are going to discuss the sums in the exercise 6.5. Okay, my dear children, we have already discussed some questions till question number 9. We have discussed so far. Okay, my dear children, are you ready to listen the class? Right. Now come to the question number 11. Okay, my dear children, I'm not explaining question number 9, 10 because it is also same as the previous questions. Okay, my dear children, right. Come to the question number 11. See the question number 11. It is given that at x is equal to 1, the function x power 4 minus 62x square plus ax plus 9 attains its maximum value on the interval close interval 0 comma 2. Find the value of a. Understood this question, my dear children? In the previous questions, the function is given completely. Every term of the function is given clearly, and we found the critical point as well as the maximum value and the minimum value of the given function. But on the other hand, here critical point is given at x is equal to 1. Here is a critical point, and function is not defined completely. See here, this third term is not given. The value of a is not given numerically. You observe this point, my children, right? But it is given that this function attains its maximum value in this interval. Understood this question, my children? Then we have to find the value of a. Okay, my children, right? Now come to the solution part. Let us assume that given function is f of x. Okay, my children. So let f of x is equal to x power 4 minus 62x square plus ax plus 9. Understood this step, my children? We assumed the given function is f of x. Then immediately what should we find? F dash of x. We have to find the derivative of this function. So what is the derivative of this f of x? It is denoted by f dash of x. Understood LHS, my children? Right. That is equal to, come to RHS. What is the derivative of x power 4? It is in the form of x power n. So we use d by dx of x power n formula. What is the derivative of this term? 4x cube. Understood this first term, my children? Understood this 4x cube, my children? Right. We write to minus a sign as it is. Okay, my children? Now come to the second term, 62x square. We write the numerical coefficient 62 separately. Then what is the derivative of x square? It is also in the form of d by dx of x power n. We use that formula here. Then what you get here? 2x. Isn't it or not, my children? We are calculating the derivative of this function in our mind itself, my children. Can you do it in our mind? Right. So we get here 2x. 62 into 2x. What will you get? 124x. Understood this part, my children? Understood this 124x? Right. Now come to the third term. What is the third term here? ax. Here a is a numerical coefficient. Okay, my dear children, we write it separately before that differential operator. Then we write d by dx of x. But we are not writing here d by dx of x. We are imagining that part d by dx of x. What is the value of d by dx of x? 1. So a into 1. What will you get here? A only. Understood this term, my children? Right. Come to the last term. What is the last term? 9. It is a constant term. Then what is the derivative of the constant term? 0. So we are not writing here 0. Understood this step, my children? Right. We have found f dash of x in this step. Okay, my children? Understood? And it is given that the function f attains its maximum value on the interval 0 comma 2 at x is equal to 1. It is given in the question itself. It is given that. So let us find f dash of 1 is equal to 0. Okay, my children, we substitute x is equal to 1 in this function and equal to 0. Okay, my children, because this is a critical point, x is equal to 1. So f dash of x is equal to 0. But what is x value here? 1. That is why we are substituting x is equal to 1 in f dash of x. Understood, my children? Right. This implies in this expression we are substituting x is equal to 1. So 4 into 1 cube. What will you get here? First term value 4 only. Understood this first term 4, my dear children? Right. We write minus a sign as it is. 124 into what is the value of x here? We are substituting 1. 124 into 1. What is the value of 124 into 1? 124. Understood this 124, my children? Right. Plus a. We write this first plus a term as it is equal to 0. Understood this term, my children? Understood this step? Right. By solving this equation, what will you get? A value 120. Understood this value, my children? 120. Yes. Hence, the value of a is 120. Understood, my children? Right. Hereafter, we apply the derivatives concept in our daily life. Practical problems. These are all practical problems. Okay, my children? Right. Come to the question number 13. 13th question in the exercise. Find two numbers whose sum is 24 and whose product is as large as possible. Means maximum. The product of the two numbers. The product of the two numbers must be maximum. Understood this question, my dear children? Right. Now come to the solution part. Let one number be x. Let us assume that one number is x. Then the other number is 24 minus x. Isn't it or not, my dear children? Because the sum of the two numbers is 24. So if the first number is x, then the second number automatically 24 minus x. Isn't it or not, my dear children? Right. Understood this step, my dear children? Right. Let p of x denote the product of the two numbers. Let us assume that the function p of x denote the product of the two numbers. Okay, my children. Then p of x is equal to, what is the first number? X. What is the second number? 24 minus x. Then we have to find the product of these two numbers. What is meant to be product of two numbers? We have to multiply these two numbers. So x into 24 minus x. So we wrote p of x is equal to x into 24 minus x. Understood this step, my children? Understood this function p of x? Right. That is equal to, now we use the distributive property, x into 24. What will you get here? 24 minus x into x. What will you get here? X square. Understood this step, my children? Right. So this is the given function p of x. In the previous questions, they gave this p of x, the function given directly. Okay, my children, we have found critical points. After that, we have found maximum value and minimum value of the function. But here, we had to write the given function also. By using the given data, we have to write the function also. Understood, my children? Right. After that, we will know the function here. After that, what should we find for what is the first step? We have to find the derivative of this function. So, what is the derivative of p of x? Yes, p dash of x. We denote the derivative of p of x by p dash of x. Understood? LHS, my children? Right. Is equal to, come to RHS. There are two terms. We write derivative of this term separately and we write the derivative of this term separately. So here first come to the first term. 24 is numerical coefficient. So we write it separately. Then what is the derivative of x? 1 only. So 24 into 1. What will you get here? 24. Understood this 24, my children? Now we got 24 here. Right. Right. After that, we write minus sign as it is. Now come to the second term, x square. It is in the form of d by dx of x power n. Okay, my children, we are finding the derivative of these terms in our mind only, and we are writing its derivative directly here. So d by dx of x square. What is the value of d by dx of x square? 2x, because it is in the form of d by dx of x power n. What is the formula for d by dx of x power n? N into x power n minus 1. So by using this formula, we found the derivative of this function. Then what is the derivative of this function? 2x. Understood this 2x, my children? Right. Understood this step, my children? Right. After that, immediately we find second derivative. What is the derivative of p dash of x? How do you denote the derivative of p dash of x? Yes, p double dash of x. the derivative of p dash of x is denoted by p double dash of x. Understood this LHS, my dear children? Right, is equal to, come to RHS. There are two terms. We find the derivatives of these two terms separately. Let us come to the first term. What is the derivative of this first term? 0, because it is a constant term. So derivative of this constant term is 0. So we are not writing that 0. Now come to the second term. We write minus sign as it is here. Then what is the derivative of this second term? 2x. So 2 is numerical coefficient. We write it separately. And what is derivative of this x? 1. So 2 into 1. What will get to? 2 only. Understood this 2, my dear children? Right. So we got here p dash and we got here p double dash also. If you observe here, p double dash is a negative number. Isn't it or not, my dear children? It is a negative number. If p double dash of x is a negative number, what can you say about the function? The function has maximum value. Okay, my dear children. So let us find the critical point. What should we do to find the critical point? We had to solve the equation p dash of x is equal to 0. Do you remember these steps, my dear children? Right. So what is p dash of x? 24 minus 2x. So 24 minus 2x is equal to 0. We write that equation. Then by solving that equation, what will you get x value? 12. Okay, my children, directly we are writing the values. We are writing the steps here directly. Understood, my children? Do that calculation part in rough work. Okay, my children? Understood? Right. Also, here p double dash of x is less than minus 2, less than 0, minus 2. So, it has a maximum value. Without substituting, automatically it is negative. So it has a maximum value. Therefore, what can you say by second derivative test? When x is equal to 12, it is a point of local maximum. It is said to be point of local maximum. This is a critical point. This critical point or turning point or stationary point is said to be point of local maximum of p, of this function p. Hence, the product of the numbers is maximum. When the numbers are 12 and 24 minus 12, what will get here? 12. By substituting x is equal to 12 in this second number, what will get? 24 minus 12? Yes, second number is 12. First number is 12 and second number is also 12. So we got the required two numbers. Understood, my dear children? Right. Now come to the question number 14. Come to the 14th. Find two positive numbers x and y such that x plus y is equal to 60 and xy cube is maximum. Understood this, my dear children? Here x and y are two positive numbers. And also the relation between x and y are given like this. X plus y is equal to 60. And this is the function. Actually, this function should be maximum. If this function is maximum, then what are the two numbers? Understood this question, my dear children? Right. The two numbers are x and y such that x plus y is equal to 60. We wrote the given data here. Understood this step, my dear children? Right. From this equation, we found the value of y. Then what is the value of y? Y is equal to 60 minus x. Understood, my dear children? This is step. Understood this step, my dear children? Right. Now come to the function. Previously I told you this is the function. This function should be maximum. So let f of x is equal to x into y cube. Understood this step, my dear children? We assumed here this is the given function and we assumed f of x is equal to x y cube. Okay, my dear children? So we have to find f of x is equal to x into, what is the value of y? 60 minus x. We have found here. So we substitute that value here. 60 minus x whole cube. Understood this step, my children? Right. We got here f of x. Like this, we have to write the function first. In the previous questions, till the question number 10, they have given the function directly. But from 13th question onwards, we have to write the function also. Okay, my children? That part also should be done by us. Okay, my children? Right. After finding the function, we have to find its derivative. What is derivative of f of x? How do you denote? F dash of x. Okay, my children, understood? LHS, right, is equal to, come to RHS. It is in the form of UV, where U is equal to x and V is equal to 60 minus x whole cube. Here we use UV formula, product rule. Okay, my children, we are doing that part in our mind and we are writing this step directly. Okay, my children, right. So derivative of this function, what is derivative of this function? 1 only, into second function we write 60 minus x whole cube. We wrote as it is, u dash into v. Okay, my children, plus we had to find its derivative into this function we write as it is. So x we wrote here x. Understood this part, my children? Now we have to find derivative of 60 minus x whole cube. If you observe this function, it is in the form of x power n, d by dx of x power n. We use that formula as well as chain rule also. Okay, my children, we have done many questions by using d by dx of x power n and as well as chain rule. We use that two parts here. So n into, here n means 3. So 3 into x square means 60 minus x whole square. Understood this part, my children? Again we have to derivative of this function. Find the derivative of this function. What is the derivative of minus x? Minus 1. So we got here minus sign. So minus 3x into 60 minus x whole square. Understood this step, my children? We wrote directly here by taking the derivative of the given functions. Okay, my children, understood? Right. Here, if you observe, there are only two terms. 60 minus x whole cube is the first term. Minus 3x into 60 minus x whole square is the second term. Okay, my children. From these two terms, we can take out the common factor 60 minus x whole square. It is a common factor in the two terms. So we are taking out this common factor out. Then what you get here? 60 minus x. From the first term, we get a 60 minus x. Understood? This is 60 minus x, my children? Right. From the second term, we get only minus 3x because we have taken it out. Okay, my children, understood this part, my children? Right. That is equal to, we write this 60 minus x whole square as it is. Now we simplify these numbers in these brackets. 60 minus x minus 3x. What will you get by simplifying these two terms? Minus 4x. Understood this step, my children? Right. Okay, my children, this is f dash of x. Now immediately we have to find second derivative. What is the second derivative of f of x? F double dash of x. Derivative of f dash of x is denoted by f double dash of x. Understood, my children? Right. Then come to RHS. Again here UV rule. Again we use UV rule. Okay, my children. So we write this function 60 minus 4x. We wrote this function as it is. We are finding the derivative of this function. It is in the form of d by dx of x power n. So 2 into 60 minus x into, again we use chain rule, means 60 minus x. Derivative of 60 minus x is minus 1. So finally we get here minus 2 of 60 minus x. Understood? This is minus 2 into 60 minus x, my children? Right. Minus, we have to find the derivative of this function. We write this function as 60 minus x whole square into, what is the derivative of this function? Minus 4. Isn't it or not, my children? Derivative of 60 is 0. What is the derivative of minus 4x? Minus 4 only. So minus 4 into 60 minus x whole square. Understood this step, my children? Right. Here also we are taking common factors. Here minus 2 and 60 minus x. These two are common factors. From these two terms we are taking out. So that is equal to minus 2 into 60 minus x. By taking these two common factors out, what will you get from the first term? 60 minus 4x. Understood? This is 60 minus 4x, my children? Right. From the second term, after taking minus 2 into 60 minus x out, what will you get here? 2 into 60 minus x. Understood this second term, my children? Understood this step, my children? Right. This is f double dash of x. Understood this step, my children? Right. When x is equal to 0, when x is equal to 0, f double dash of x is equal to 0. Okay, my children. Here we have to find the critical points. Okay, my children. So if you take 60 minus x is equal to 0, then we get x is equal to 60. So f double dash of x is 0. When x is equal to 15, how do you get 15? 60 minus 4x is equal to 0. Then what will you get? X value 15 only. So when x is equal to 15, these are the two critical points we get by solving the equation f dash of x is equal to 0. Okay, my children. Here we got 60 minus 60 and 15 are two critical points. It was done here. After finding these two critical points, we substitute in f double dash of x. Here we got 0. When we substituted x is equal to 0, we got f double dash of x is equal to 0. So we ignore this point. When x is equal to 15, then f double dash of x is equal to negative number, so less than 0. So by second derivative test, if x is equal to 15, okay, my children, this x is equal to 15 is a critical point or turning point or stationary point. This is also called a point of local maximum of f. Okay, my children, this is another name. Understood this point, my children? Right. Thus, the function xy cube is maximum when x is equal to 15 and y is equal to 60 minus 15. To find the second number, we substitute x value here. Then what do you get? 60 minus 15. That is 45. So the first number is 15 and the second number is 45. Understood, my children? Right. Here I am not explaining the question number 15 and 16 because question number 15 and question number 16 are same as that of question number 14. Okay, my children? Right. That is why I am explaining question number 17. Come to the 17th question. See this question. A square piece of tin of side 18 centimeters is to made into a box without top by cutting a square from each corner and folding up the flaps to form the box. Understood this point, my children? Right. What should be the side of the square to be cut off so that the volume of the box is maximum possible? Understood, my children? We have to find the volume. That volume should be maximum. Here function is volume. Okay, my children? Volume of the tin, volume of the box. That volume of the box should be maximum. Understood this point, my children? Right. Come to the solution part. Let the side of the square to be cut off as x centimeters. We have cut x centimeters square from the four corners of the piece of tin. Okay, my children. Then the length and the breadth of the box will be 18 minus 2x centimeters each. And the height of the box is x centimeters. Understood this point, my children? Length and breadth are 18 minus 2x only, but height of the box is x centimeters. So we got the dimensions of the box: length, breadth and height. Okay, my children, understood this point? Right. Therefore the volume v of x, we are denoting this function as v of x, volume. So we are using letter v. Understood this point, my children? Right. V of x of the box is given by V of x is equal to length into breadth into height. Okay, my children. So length is 18 minus 2x into breadth is also 18 minus 2x. 18 minus 2x into 18 minus 2x. What will you get? 18 minus 2x whole square into height. Height is x. We substituted length, breadth and height in this formula. Do you remember the formula, my children? Volume of a cuboid. So length into breadth into height. In that formula, we substituted the three dimensions of the box. Understood this step, my children? Right. This is the function. Actually, this is the function. V of x is equal to x into 18 minus 2x whole square. Understood this step, my children? Right. Immediately, we have to find derivative of this function. We have to find the first derivative of this function. How do you denote first derivative of this function? V dash of x. d by dx of vx is denoted by v dash of x. Understood LHS, my children? Right. That is equal to, come to RHS. It is in the form of UV. So we use here product rule. UV rule. d by dx of UV. Okay, my children? So u dash into v means what is the derivative of x? 1. So we are not writing 1 here. Into v, we write this second function as it is, 18 minus 2x whole square. Understood this first term, 18 minus 2x whole square. Right. Now come to the second term. We write x as it is. We wrote here x. Understood this part, my children? We wrote x as it is. We are finding the derivative of this function. Now it is in the form of d by dx of x power n. Okay, my children? Recall that previous knowledge. It is in the form of d by dx of x power n. Then how do you find n into x power n minus 1? We use that formula. So where n is equal to 2 and x means 18 minus 2x. So we get 2 into 18 minus 2x. Again we have to derivative of this function. We find derivative of this function. So derivative of this 18 is 0 and derivative of this term is minus 2. So already 2 is there. So minus 2 into 2. We get minus 4 into x into 18 minus 2x. Understood this step, my children? We calculated every derivative in our mind itself. Otherwise, you can find the derivative of this function in rough work. Then you get this step only. Understood this step, my children? Right. If you have any doubt, do this part in rough work. Okay, my children? Right. If you observe, there are two terms. What are the two terms? 18 minus 2x whole square is the first term. Minus 4x into 18 minus 2x is the second term. From these two terms, we can take out 18 minus 2x common factor. So after taking out 18 minus 2x out, the common factor, from the first term, what will you get? 18 minus 2x. Understood this 18 minus 2x, my children? Right. From the second term, if you are taking out 18 minus 2x, what will be left here? Minus 4x. Understood this minus 4x, my children? Understood this step, my children? Right. That is equal to, we write this 18 minus 2x as it is here into, in this brackets, we are simplifying the terms, like terms. We write 18 as it is. Here these two terms are like terms. So minus 2x minus 4x. What will you get by simplifying these two terms? Minus 6x. Understood minus 6x, my dear children? Understood this step, my children? Right. That is equal to, again we are taking out 6. Okay, my dear children? 6 into, from this factor, we are taking out 6 common factor. Okay, my children? And from this factor we are taking out 2. From this factor we are taking out 2 and from this factor we are taking out 6. Then what will you get after taking out 2 from these two terms? 9 minus x. Understood this part, my children? 9 minus x. Right. By taking out the 6 common factor out, what will you get here? 3 minus x. Understood this 3 minus x, my children? Understood this step, my children? Right. 6 into 2, what will you get here? 12. So 12 into, understood this 12, my children? Right. 12 into, we write these two factors as it is. So 9 minus x into 3 minus x. Understood this step, my children? This is v dash of x. We got here v dash of x. Immediately we had to find its second derivative. d by dx of v dash of x. How do you denote it? V double dash of x. Okay, my children, understood LHS? Right. Come to RHS. This is the numerical coefficient. We write it separately. Now we find the derivative of this function. It is in the form of uv. Isn't it or not, my children? Right. So we have to use the formula product rule. So we find d by dx of 3 minus x. What is the d by dx of 3 minus x? Minus 1. Understood minus 1, my children? Into, we write 9 minus x. Understood this 9 minus x, my children? Right. Now we write 3 minus x as it is. We find the derivative of this function. What is the derivative of this function? Minus 1. So minus 1 into 3 minus x. Understood this minus of 3 minus x, my dear children? Understood this step, my dear children? Right. That is equal to, we are taking minus common. Then what we get here? Minus 12 into. Then what will you get the terms in this square brackets? 9 minus x plus 3 minus x. Understood this 9 minus x plus 3 minus x, my dear children? Right. Understood this step, my dear children? Right. That is equal to minus 12 into. Now we simplify the terms in these brackets. 9 plus 3. What will you get here? 12. Understood this 12, my dear children? Right. Minus x minus x. What will you get? Minus 2x. Understood this minus 2x, my dear children? Right. Understood this step, my dear children? Right. Again we are taking out 2 common. So minus 2. We are taking 2. So 2 into minus 12. What will you get here? Minus 24. Understood this minus 24, my dear children? Into what we'll get in these brackets after taking out 2 common factor. Here we get 6 minus x. Understood this is 6 minus x, my dear children? Understood this step, my dear children? Right. We got here v double dash of x. We got here f dash of v dash of x, and here we found v double dash of x. Then after that, what should we find? Third step, we have to find critical points. How do you find the critical points? By solving the equation v dash of x. In the place of f dash of x, we are writing v dash of x. Understood this third step, my children? Right. What is v dash of x here? 12 into 9 minus x into 3 minus x. Here no need to take this number. We take these two numbers. Then what will you get here? 3 minus x is equal to 0. Then what will you get? X is equal to 3 and 9 minus x is equal to 0. Then what will you get? X is equal to 9. So we got here two critical points, namely 3 and 9. Understood these two values, my dear children? These two are also said to be point of local maximum or local minimum according to the question. Here maximum. So these two are said to be points of local maximum. Understood this point, my dear children? Now if x is equal to 9, now we substitute these points. Do you remember that, my dear children? Fourth step, we have to substitute these critical points or stationary points or turning points in v double dash of x. Then we get 0. If x is equal to 9, we get v double dash of x is 0. So we ignore this number. Then we substitute x is equal to 3. So if x is equal to 3, then v double dash of x value is minus 72. So is it a positive number or negative number? Yes, negative number. So it is a less than 0. So v double dash of x, we got here a negative number. Means what can you we say that the given function has maximum at x is equal to 3. So by second derivative text, x is equal to 3 is the point of maximum of v. Hence we remove a square of side 3 centimeters from each corner of the square tin and make a box from the remaining sheet. Then the volume of the box obtained is the largest possible. Understood this point, my dear children? If you cut the square of side 3 centimeters from each corner and by the remaining sheet, by using the remaining sheet of the paper, remaining sheet of the tin, if you prepare a tin, then its volume is maximum. Understood, my dear children? Right.